Hi, welcome to VHL Academy. Let us discuss with the previous lecture. So, what we have been discussing that degree of static indeterminacy, that is the ds is equal to dse plus dsi. dse plus dsi, where dse is static external indeterminacy. Yes, external indeterminacy. Static external indeterminacy is due to support reactions. And next one is dsi. dsi is equal to internal indeterminacy. Internal indeterminacy. It is due to the members provided. Right? ds is equal to dse plus dsi. And the next one is types of framed structures. Types of framed structures. Types of framed structures. In this, the first type is pin jointed plain truss. Pin jointed plain truss. It is again classified into two types, which are the first one is pin jointed plain truss. The next one is pin jointed space truss. In this pin jointed plain truss, the example for this is a truss. The example for this is a tower. In this pin jointed plain truss, the only force acts which is axial force. Axial force. Only one force acts, which is axial force. Right? The next one is rigid jointed frame structure. Rigid jointed frame structure. It is again classified into two types, which are rigid jointed plane frame. Rigid jointed plane frame. And one more is, the second one is rigid jointed space frame. Space frame. The example for rigid jointed plane frame is a beam, comma column. The example for rigid jointed space frame is a building, or frames. A building, right? Here, rigid jointed plane frame, three forces mainly acts, which are axial force, shear force, and bending moment. Here in rigid jointed space frame, axial force, shear force, bending moment, and torsional movement. Here axial force, shear force and movement. In space frame, axial force, shear force and movement and torsional movement. Right? The next one is pin jointed plane truss. We discuss about this. Pin jointed plane truss. We discuss about this. Let us say this is a truss. A truss. This is hinged joint. And it is roller support. In truss, each joint is a pinned joint. Each joint is a pin joint. So, let us draw a free body diagram for this truss here. This is FBD of whole structure. FBD of whole structure. FBD of whole structure. Now, what I am going to do here is I am taking a member AB from this whole structure and drawing a free body diagram for that member AB. That is, this is a member AB. The forces acts on this member are this way. Here it is in this way. Sorry. At every hinge joint, the property of hinge joint is only two forces, two reactions or two equilibrium equations available, which are in x direction and y direction. I want to take a resultant of these forces here. That is, it gives the resultant of these two forces are like this. The resultant of these two forces are like this. The resultant of forces at B, the resultant of forces at A. By this resultant of forces of the free body diagram, this member AB is not in equilibrium. Is not in equilibrium. Because of not, the member is in equilibrium, so the member is not in stable condition. The member is not in stable condition. For that, what we have to do for a stable condition, we have to give the equilibrium equation. That is in this direction. This is a member AB. If I apply a force in this direction, then the member AB is in equilibrium, or it can be like this, or it can be like this. Then only the member could be in stable or equilibrium. So, by this, I am again drawing a free body diagram for the joint B. This is a joint B. To balance this force in this member, the force developed here joint B in this direction. To balance the force in this member, again the force develops in this direction. For this member is in this direction. So by this, what I want to emphasize you here is the sign convention to decide whether the force in which direction, and what we have to consider whether it is negative or positive. That is the sign convention. The sign convention in this direction, we take it as tension. A tension that is positive. Positive. As per algebraic, this is we take positive for algebraic equations. This is for algebraic. This is for direction of force in tension. Right? The next one, Here each member has a force, one force, that is an axial force. That is an axial force, right? And the support has the number of reactions. A support has the number of reactions. So here R is equal to total number of reactions. Total number of reactions. And M is equal to the total number of member force. M is equal to the total number of member force. The total number of member force. And J is equal to total number of joints. Total number of joints. See here in truss, each joint is a pin joint. Since it is a pin joint has two equilibrium equations. Two equilibrium equations. So, at one joint, there are two number of equilibrium equations are available. For J number of joint, 2 into J number of equilibrium equations are available. That is 2J. Total number of equilibrium equations available. The unknown quantities here are reactions plus the number of members. In each member, an axial force is developing. So, the R plus M is equal to an unknown quantity. Unknown quantity. Right? Let us go back to our degree of static indeterminacy definition. What it says, ds is equal to the number of unknown reactions or the number of unknown quantities minus the total number of equilibrium equations available. By this, we can write the unknown quantities here is M plus R minus the total number of equilibrium equations are available. Here the number of equilibrium equations available are 2J. At each joint there are two equilibrium equations available. For J number of joint, 2 into J. That is the degree of static indeterminacy. ds is equal to M plus R minus 2J. Minus 2J. Right? For external indeterminacy, DSE is due to the support reactions. By this, the support reactions are R minus the number of equilibrium equations available in plane frame, plane truss. 3 number of equilibrium equations available. By these two equations, we can write the DSI, degree of internal indeterminacy. Degree of internal indeterminacy, that is ds minus dse. By this, R plus M minus 2J minus this R minus 3. If you solve this, r plus m minus 2j minus r plus 3. This r goes cancel. And finally, m minus 2j minus 3. This is DSI, degree of internal indeterminacy. Degree of internal indeterminacy. Here, if m is equal to 2j minus 3, if m is equal to 2j minus 3, the truss is stable. The truss is stable. The truss is stable. The truss is stable. If m is greater than 2j minus 3, the truss is stable and indeterminate. Here the stable and determinate. If m is less than 2j minus 3, the truss is unstable. In this first case, if m is equal to 2j minus 3, the truss is stable and determinate. In second condition, if m is greater than 2j minus 3, the truss is stable and indeterminate. In third condition, if m is less than 2j minus 3, the truss is unstable. Here, m is equal to the number of members required. The number of members required. The number of members required. And 2j minus 3, 2j minus 3 is equal to the number of members required, and 2j minus 3 is equal to the number of members provided. The number of members provided. The number of members provided. The next one is for space truss. Pin jointed space truss. Pin jointed space truss. We already discussed that in plain truss. Similarly, plain truss, in space truss, the degree of static indeterminacy is equal to m plus r minus 3j. m plus r minus 3j. where M is the number of members, R is the reactions, and J are the total number of joints. Right? And the next one is rigid jointed plane frames. Rigid jointed plane frames.